For medium and harder questions, the SAT likes to mix the topics of similar triangles and trigonometry. And the good news is it's pretty straightforward once you remember a very important fact about similar triangles. And that is when you have two triangles that are similar, corresponding angles are congruent. And they told us that P, Q, and R correspond to X, Y, and Z. But a little trick, when you're given kind of the definition of these triangles, P, Q, R, X, Y, Z, the order of these letters shows the correspondence. So P would go with X and Q with Y and so on. And they did tell us that, but technically they don't need to. So if these angles correspond, it means they are congruent. So Q, of course, and Y are both right angles, so they're congruent. But R and Z, which correspond, must be congruent. And then P and X, which correspond, must also be congruent. So what does this tell us? Well, if we're looking for the cosine of Z and we're given the cosine of R, notice what we're dealing with are two angles that correspond. In other words, they're congruent. And so if angle R and angle Z are congruent, then the cosine of R would have to equal the cosine of Z. And since the cosine of R we are given is 0.263, we know the cosine of Z must be 0.263. And so 0.263 is our answer. Now, there are harder versions of this question where instead of giving you the cosine of R, they'll give you sides of the triangles, and you have to use SOHCAHTOA to find the sine or the cosine or tangent. But it's the same basic idea. Once you know those triangles are similar, you can see which angles correspond and therefore which are congruent. And therefore, you can use that fact to find the trig functions or to find information about the angles of those triangles, given that you have these pairs of corresponding congruent angles. So in this case, though, we do get 0.263 as our answer.